Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel Pharma World. Today's topic is powder flow as per USP chapter 1174 and EP 2.9.36. Powder characteristics are very important to ensure uniform flowability of the granules. Uniform flowability is required to get consistent dosage forms across the batch. In this video, we will look into common analytical methods to establish these characteristics. Powder flow. Powder flow is a specific characteristic for pharmaceutical powders. There are a variety of test methods to characterize the powder properties. The intent is that the flow of materials should be consistent throughout the process. This behavior of pharmaceutical powders is useful for further processing of these powders into dosage forms. Following are the important characteristics of powders: angle of repose, compressibility index or Hausner ratio, flow rate through an orifice, and shear cell. The last two are rarely used and hence not discussed in detail in this video. Angle of repose. Let us consider the most frequently used test, angle of repose. Common aspects for determining the angle of repose are as follows. Take a clean and dry funnel and fix at a height of 2 centimeters or 3 centimeters. This is important. The funnel should be totally clean and dry. It should be free from oily or sticky stuff. Otherwise, the powder is likely to stick to the sides of the funnel. Make sure that the base on which the funnel is fixed is vibration free. A firm burette stand is a good setup for this. The table should be free from vibrations. Place a white paper under the funnel. Make sure that there are no air currents to disturb the paper from the base. Take the sample and gently break the lumps, if any, to make it free flowing. This is to ensure that the entire sample is free flowing without any lumps. Lumps can hinder the flow through the funnel. Slowly pour the sample into the funnel till the tip of the heap touches the tip of the funnel. The tip may be adjusted if the material passes through the funnel, does not touch the tip, or goes over the tip of the funnel. The height may be adjusted depending upon the sharpness of the heap. As discussed in the previous slide, the height of the funnel may be adjusted if required. Carefully mark a circle around the bottom of the heap with indelible ink. Measure the diameter across 4 points on the circle. So mark the circle with pencil or pen carefully around the heap on the paper. Remove the powder from the paper and transfer it into the container. Measure the diameter across the circle at 4 points. Take average of the diameter in centimeters. Calculate the angle of repose theta as per the formula. Tan theta is equal to height of the heap divided by 0.5 times of the diameter of the circle, which is the radius. So obviously theta will be tan minus of height of the heap divided by 0.5 times of the diameter of the circle. In this, the height of the heap is a fixed height of the funnel. In the above example, the height was fixed. Alternatively, base may be with a fixed diameter and the sample is poured from the funnel till the heap is no more increasing. This is another method. A fixed base is taken. The base will be fixed on the firm base and slowly the sample will be poured through a funnel till there is no increase in the heap formation. That means the heap has achieved maximum height. The diameter of the base also can be changed if required depending upon the pile formation. So the diameter can be altered if required. In this, the height is measured, diameter is constant. In this technique, the height is measured. Calculation is done as in the earlier method. Calculation is same as in the previous slide. The angle of repose is measured in degrees. These are typical characteristics of the powder depending upon the angle of repose. You can notice that lower the angle of repose, the better the flowability. Compressibility index and Hausner ratio. The compressibility index and the Hausner ratio are closely related. So let us see more. In fact, compressibility index and Hausner ratio are not separate tests. These are derived from the bulk volume or density of the powders. The compressibility index is an indirect measure of bulk density, size and shape, surface area, moisture content and cohesiveness of the materials. These characteristics largely impact the disintegration pattern, dissolution pattern, size of the dosage form, etc. The development of dosage forms is done using all these factors. The compressibility index and the Hausner ratio are determined by measuring both the bulk volume and tapped volume of a powder. This has to be understood that a known weight of sample is poured into the measuring cylinder and the volume is measured. Volume before tapping is called bulk volume or apparent volume. Some call it also as loose volume. Tapped volume is the reduced volume after certain tapping as prescribed in USP chapter 616. Prescription as in USP chapter 616 is recommended to carry out the bulk volume, apparent volume and tapped volume. So USP chapter 616 provides more details on carrying out of the bulk density test. You may have to go through that chapter. The calculation for compressibility index is as follows. Compressibility index is equal to 100 multiplied by V0 minus Vf divided by V0, where V0 is the bulk volume or apparent volume and Vf is tapped volume. Alternatively, it can be calculated as follows. Compressibility index is equal to 100 multiplied by D tapped minus D untapped divided by D tapped, where D tapped is tapped density and D untapped is untapped density, that is apparent density. This is a simple calculation. If the bulk volume, tapped volume values are known, it can be calculated. Also, when the bulk density and tap density values are also known, the compressibility index can be calculated. Remember, the bulk volume will be always higher than the tapped volume. After tapping, the volume reduces, whereas the tapped density is always higher than the bulk density or apparent density. The calculation for Hausner ratio is as follows. Hausner ratio is equal to V0 divided by Vf. Alternatively, it can be calculated as follows. Hausner ratio is equal to D tapped divided by D untapped. Hausner ratio is calculated using these formulas when the bulk volume, tapped volume, or bulk density and tap density values are known. These are typical values for Hausner ratio. Values around 1.00 to 1.11, the flow characteristics are excellent. When it is more than 1.60, the ratio is very poor. Flow rate through an orifice and shear cell properties are less frequently used in pharmaceutical industry. Hence, these are not discussed in this video in detail. If there is any specific request from anyone, it will be discussed in more detail in coming up video programs. In this video, mostly used tests angle of repose, compressibility index and Hausner ratio are discussed. I hope that this gives clear insight into these tests. Also, try to read USP chapter 1174 and EP 2.9.36 chapter for more details. Thanks for watching. For more videos, please do subscribe, like and share. Thank you.